Hey guys, my name is Mr. B, and today I'll be doing my first of many lectures that I'm going to start for MCAT preparation. So, student doctors, if you stick with me, this lecture will be about MCAT Math. After MCAT Math, I will be teaching physics, and then chemistry, organic chemistry, biology, and biochemistry, and I might do a psych-soc section at the end, but I haven't decided yet. But today's lecture will be over MCAT Math and how to approach math questions or math application questions on the MCAT. And so the major topics today will be rounding, square roots, trigonometry, we'll be talking about the unit circle, scientific notation, how to multiply two different exponents together and add them, subtract them, how to deal with proportions, and how to analyze graphs. So the first topic we're going to talk about is rounding. So the importance of rounding for the MCAT is that, it's important to shorten the time it takes per question. So usually you have about a minute and 30 seconds per question. If you use most of your time to calculate, 23 times 15 or 23 times 10 to 10.9 raised to the fifth, then you know what? This is probably going to take you way longer to calculate this than it is for you to get through 10 questions with rounding, rounding. So that's why I'm going to teach you how to round. So let's look at both of these examples. The way I would approach this question right here, or this multiplication right here, is to look at it from two perspectives, okay? So we know that 23 times 15 is going to be in between, right? It's going to be in between 20 times 15, which is easy, right? 15 times 2 is 30. Just add a 0 to that, 300. And we can do, what else? We can do, we can also go ahead and do 20 times 15, 300, and we can do 25 times 15, right? Or 25 times 20, and we can get a number like 500, okay? So automatically we can look and see that the number is going to be 300 and 500, okay? Or maybe this is a little better. We can do 15 times 30, okay? And we know that number is going to be 450, right? So then we know that the answer choice is going to be in between 300 and 450. Likewise, we can do the same thing for this exponent. And we can, if we wanted to, look at for our answer choice that is closest to 10 to the fifth. And, whenever we're using math calculations, if you have to multiply two exponents, as is the case if you had to multiply, 23 times 10 to the fifth times 25th times 10 to the sixth, right? It's easier to multiply these two numbers than it is to multiply these two numbers. So you're better off rounding this value to make it lower. And then, right, we can arrange this a little bit, right? And I'm going to teach you how to rearrange exponents later and round them so that you can get those numbers. But that's for later, okay? But I'm just teaching you why rounding is important, because it's going to help you. It's going to save you time. It's going to save you, it's going to help you avoid errors. And it's just going to make your timing better on the MCAT. Okay, so let's continue our sequence on rounding by using an application for square roots. All right, so let's look at this example for square roots. So our example is 2.2 squared, okay? So the closest thing to 2.2 squared is, the closest thing to 2.2 is 2 and 3. So for the MCAT, what they would like you to do, or what I would like you to do, is to save time, okay, and just take the square root of each number. So 4, we got 4, and we got 9. So the value of x is going to be in between 4 and 9, okay? And if this was an answer choice, the answer choice would be somewhere in between those two answers, okay? All right. And one more point that I would like to make is that since the value that we have is 2.2, and 2.2 is closer to 2 than it is to 3, the answer will be closer to 4 than it will be to 9. All right. So let's do another example. What would you do if you needed to find the square root of 21? Well, what are the two closest numbers? Let's do something similar to the example that we provided here. What are the two numbers closest to 21 that we know the square root of? Well, we know the square root of 25, and we know the square root of 16. So we know the square root of 16 is 4, square root of 25 is 5. So the square root of 21 will be between these two numbers, right? And that's how they want you to think, right? Remember, we're learning how to do mental math. All right, so these are two pretty clear examples. Now we're going to look at how to analyze cubed roots, and the fourth root, and we're going to see how to rewrite it and better understand how to manipulate it. All right, so let's look at this. So we're going to look at three different examples. The square root of 4, which everyone knows, right? We're going to look at the cubed root of 4. We're going to look at the fourth root of 4, okay? So let's just go ahead and rewrite these. So the square root of 4 can also be written as 4 over 1/2, right? The cubed root of 4 can be also written as 4 raised to 1/3. All right? Let me just fix that. And the fourth root of 4 can be also written as 4 raised to 1/4. And so why do we need to create the same bases, right? So when we create the same bases, we can, let's just say we had an example where they had asked you to multiply 4 over 1/2 by 4 over 1/3. Well, the point here is that you need to be able to learn how to manipulate these squares and cubes so that you can learn to manipulate and get the right answer, right? And you can simplify that further, right? So the way you would simplify is multiply by 2, right? Multiply by 2, multiply by 3, multiply by 3. Okay, so that would be 3 over 6 plus 2 over 6, right? So we have 5 over 6. and that answer would be 4 raised to 5 over 6, right? So when talking about square roots, we need to learn how to manipulate square roots, cube roots, fourth roots, so that we can multiply square roots, cube roots, and get the answer in a quick and an efficient way, right? Using the same bases. So that's one way that we need to be able to learn how to manipulate square roots. The next way that we will be learning to manipulate square roots is to just kind of see how to rearrange different examples of square roots, right? So let's just say you have 4 raised to 2 over 3, 4 raised to 2 over 5, and 4 raised to 3 over 5. All right? So what is this saying? Right? The denominator is always going to be the cubed, or is always going to be the cube. So it's the 4, and this is saying 4 raised to 2 inside. Right? The denominator is always the square root, so this is the 5 out here, and this is saying 4 raised to 2 outside, right? And this is same thing, right? Denominator is 5, 4 raised to 3, right? Right, so these are both different ways. These are both different ways of writing the same thing. And we need to be able to go from one form to another very easily just by looking at the numbers. Just in case we have to multiply, right? Divide, subtract, or whatnot. Whatever the question asks. So we need to be able to easily be able to go back and forth in terms of these different forms. All right. Now, for the MCAT, there are 2 square roots that you must memorize, okay? Because these are going to be very important, and you're definitely going to have to use these 2 numbers in some application for the MCAT. And that is the square root of 2, which is 1.4, which is approximately 1.4, but for the MCAT purposes, just use 1.4, and the square root of 3, which is 1.7. All right, so these are the 2 different numbers that we need to know. All right, the next thing that you guys must learn is the first half, or the first quarter of the unit circle. All right. So let's go ahead and draw that. All right. This is how I memorized it. Here you have the y-axis. This is the x-axis, and I don't know if this is the right way to memorize it, but this is just easy for me. So here I'm on the x-axis, right? So the x value here has some meaning, but the y value is 0. So here's 1 and here's 0. All right, and this is 0 degrees, right? And this is 90 degrees. And the same way, right, here the y value has a value of 1, while the x value is 0. So there you go, and that's 90 degrees. All right. Oh, actually, let me go ahead and erase that. Sorry about that. So, right, the x value is 0, right, and the y value is 1. And so let's go ahead and fill in the blanks here. All right. So the very first the very first degree is 30 degrees that we need to know, followed by, right? So the first increment is 30, and then the next one is 45 degrees, right? And then it's another 15, so that is 60 degrees, and then it goes to 90 degrees. So first is the increment of 30, then it's 15, then it's 15, and then it's back to 30. All right? And the way I remember this is from the 0 degree point, we go from 1 to 0, all right? So all of our x values from 0 degrees to 30 degrees to 45 degrees to 60 degrees will be decreasing. So 1 to 0 is decreasing. So all values will be decreasing. So let's go ahead and look at that. So we have the square root of 3 over 2, okay, right? And right after that, we go to square root of 2 over 2. All right, and then we'll be going to square root of 1 over 2. All right, sorry about that. And vice versa, we are going from 1 to 0 in the opposite direction for the y-axis, okay? So let's go ahead and look at that. So that is the square root of 3 over 2, right? And this is going to be the square root of 2 over 2, right? Because it's decreasing. And then it's going to go 1 over 2. And then, or square root of 1 over 2, it's the same thing, it's just 1 over 2. And it's going to get to 0, all right? All right, so please remember this because this is very important, especially when we get into physics and we need to create free body diagrams, and we'll be needing to, free body diagrams, and we're calculating forces, or when we need to break down the components of a certain force, and we need to find the x component or the y component. We'll need to know these degrees, is because those degrees are most applicable to physics, especially the first semester of physics. So that's why it's important to learn the basic trigonometries and know that first quarter of the unit circle. All right, the next topic that we're going to be talking about is scientific notation. And this is undoubtedly the most important math section, math topic on the MCAT, because we'll be working with a lot of scientific notations. So, speed of light, Avogadro's number, will be, a lot of conversion from particles to moles in chemistry. So we have to really get used to a lot of these scientific notations, okay? So, in our first example, well, first of all, I just kind of want to break down the anatomy of scientific notation, okay? So let's look at this number. So we have 1.60 times 10 to the fourth, okay? And this outside number is usually called the mantissa. All right, and this 10 right here is the base, and this 4 is called the exponent, okay? The exponent. All right, and another way of saying that 10 is the base is also referred to as the magnitude, okay? And why is it called the magnitude? Is because when we look at the mantissa and see that it's raised by 10 raised to whatever number, it's saying 1.60 times 10 times that grouping raised to that exponent. So that is almost, so in this example, this is saying we have 1.60 times 10 raised to the fourth, right? So 10 raised to the fourth is about 10,000, right? So that is the difference of that's why we call this base the magnitude, because 10 raised to 4 is saying that this value of 1.60 is represented actually by 10,000, okay? Which means this is actually 16,000 units. All right, so that's why we call the base the magnitude. All right, so the next concept that I kind of want to teach you guys is, since we already know, we kind of explained what magnitude is, it should be easy for you guys to tell me what the difference is between two exponents or two bases. Okay, so 10 raised to negative 12 versus 10 raised to negative 8, all right? So, well, let's start with something a little bit more straightforward, okay? Well, they're both straightforward, but let's do 10 times 12 to the 8 times 10 raised to 8, right? So the fact that, we have more exponents, since 12 is greater than 8, we know that 10 to the 12th is greater than 10 to the 8, right? But what if we had this example, 10 to the negative 12th versus 10 to the negative 8? Which is greater? So whenever you have a negative exponent like this, what that is saying is that if you took the number 1, all right, and you placed a dot here, that means that in order to get to this negative 12, you would have to go one second. You would have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. 0, 0, 0, 0, 0, to get to that value, okay? And same here, okay? So if you had 1 and you had 10 to the negative 8, that means you would have to go 1, 2, 3, 4, 5, 6, 7, 8 places to get to that value. So what is that saying? Which value is greater than? That means is 0.0000000000001 or 0.000000001 greater, right? So we know that this value is greater, right? All right, so let me just go ahead and erase this because we have to start talking about our next concept. And I just really want to point out what the difference in two exponents can really make, right? So if you look at, let's just say 10 to the first, right? So let's just say 10 to the first is the same as saying, you have 10 molecules here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 molecules. And then you come over here, okay? And the difference between this and 10 to the 5 is that we have, raised this number multiplied by 5, right? So the actual exponent here is actually, let's just show it in the same color, is going to be 10 to the 5th times greater than that, right? So that's the difference between 10 molecules, okay, and 100,000 molecules. You see what I'm saying? And that's a major difference that I want you to see. So you know the power of these bases, the magnitude, the difference in the magnitude that they can make. So now that we understand how scientific notation works, how the numbers are represented, and what the bases and the exponents represent not graphically, but visually, we kind of have a better understanding of what those molecules, what that difference in the molecules looks like, right? So now I'm just going to go ahead and erase this, and we're going to look at adding and multiplying in scientific notation. If we had two different numbers or two different groups of numbers that we wanted to add or multiply. All right. So let's look at this example. All right. So we have our example looks like this. Okay. So we have 5.32 times 10 to the negative fourth, and we have another number that we want to multiply, and that is 1.12 times 10 to the negative 13. Okay. All right. First thing that I always check whenever I'm multiplying is to see if the mantissas have the same decimal place. Okay, so this is the 5 is in the ones and the 1 is in the ones. Okay, and then I also look at the exponents. All right, so the second thing that we have to do is we need to learn how to multiply, right? So 5.32 times 1.12, right? We need to round those, right? So the very first step we're going to do is we're going to simplify it. So let's convert it. 5 times 10 to the negative fourth, right? Times 1 times 10 to the negative 13, okay? The next step that we're going to do, right, whenever we're multiplying in scientific notation, is always to multiply both the mantissas first, okay? So 5 times 1 is 5, all right? 5 times 1 is 5. And whenever we're multiplying the bases, okay? Whenever we're multiplying the bases, we are going to keep the base the same. So the base is going to be 10, but we're going to add the exponents. So it's going to be negative 4. Okay, so that's actually not a good color. So I'm just going to erase that. Okay, so let's go back here. So we're going to go, one second. We're going to go back here, and we are going to negative 4 plus negative 13, okay? And we're going to get negative 17, okay? And that will be our MCAT mental math answer. All right, so that will be the answer. Now remember we talked about the rounding principle, right? Look, we have to look at this number 5.32. Did we round this up or down? Well, we rounded this down, right? So if we rounded this down, then we expect that overall the answer choice that the answer that we got here, right, is actually going to be lower than the expected value on our multiple choice of our multiple choices. So your answer choice might be something. Your correct answer might be something like, 6 times 10 to the negative 17th. All right, that's the first thing that we need to understand. It might be something like 6 times 10 to the negative 17th. So now we understand how to multiply. Multiplying is pretty straightforward, right? We can, to make things easier, we can convert the mantissa to be in the same numbers place and multiply, which we did here. Since we rounded, we had to take that into consideration in our final answer. For our base, we remember whenever we multiply bases, we have to add the exponents, right? So we added -4 and -13, and we got -17, right? And we kept the bases the same, right? Now what would happen if we had to divide these two answers? So let's go ahead and do that example. So I'm just going to go ahead and erase all this. All right, let's just erase all this, and I'm going to go ahead and divide these two numbers. Okay. All right, 1 second. It's just taking a little bit of time. All right. So now let's just say we divided these two numbers, okay? So we have 5.32 times 10 to the -4. And we had to divide that by 1.12 times 10 to the -13. 0.12 times 10 to the -13. So same thing as before, right? Instead of multiplying, now we're dividing. We would round these two numbers, right? 5 divided by 1 is 5. All right. And we would keep the base the same, 10, 10. Now, the only difference is that instead of adding now, we're going to subtract. So -4 minus -13, right? Now we're going to add 13 is going to be 9. So if we divided it, it would be 5 times 10 to the 9. And that would be our answer. So now we understand that when you're subtracting, it's pretty much the same thing. The only difference is that instead of multiplying, now we're just dividing here, and instead of adding, now we're subtracting there. And that's how we came up with this 5 times 10 to the 9th. Okay, so now let's go ahead and erase this. So I'm erasing all of this. And now we're going to talk about addition and subtraction. All right. Let's do addition and subtraction. Addition and subtraction, okay? So let's go ahead and do some addition and subtraction. So let's look at this example that we have here. So let's use a simple one, okay? So let's say we wanted to add 2.76 raised 10 to the 4th and 2.86 times 10 to the 4th, okay? Once again, right, we'll just use our rounding rules, and when we're adding here, all we would do is we would keep, right, the bases are the same, because we're not changing the quantity in anymore, right? The magnitude, remember, we talked about the difference in the magnitude when we drew the two jars, right? And we talked about how the exponents, the base shows the degree of the magnification of the molecules, right? So when we have 10 to the 4 and 10 to the 4th, they're going to be the same, right? So we're going to keep those bases the same because we're only adding. If we were multiplying, that would be a completely different story, right? Instead of being 10 to the 4 times 10 to the 4, it would be 10 to the 8 now, right? So that's something that you have to know. So addition is separate. It's different. So here, since we're adding 2.76 plus 2.86, we can round those to 3 and 3, so we can just simplify that and say that it's 6. So instead of multiplying, now all you're doing is adding, and that's how we got 6 times 10 to the 4th. All right, so let's go, and that is how simple addition is. Now it can get a little bit complicated, and let's just look at this next example so we can see how we are going to correct that issue. All right, so let's look at that example. All right. So in this example, let's just say we have 2.76 times 10 to the fourth, and we need to add this to 6.91 times 10 to the fifth, okay? So now we have a problem, okay? So what is our problem, you may ask? And I will tell you that the problem is that our bases, or our exponents, are not matching, right? This is 5, this is 4, all right? So how will we resolve this issue, okay? So now we're going to talk about Lars, okay? Which says that if you move left, so it's which says left, we're going to add an exponent. And if it says right, it says subtract exponent, okay? So here's the issue, all right? We need to make these numbers the same, all right? Is 10 to the fifth greater than 10 to the fourth? Yes, it is. So now what we need to do is we need to move this to the fourth. So we're going to move it to the right. So if we have 10 to the fifth and we want to create 10 to the fourth, do we add or do we subtract? We have to subtract, right? So right, subtract. We have to move this decimal point to the right, okay? And that is going to result in us subtracting 1 from the exponent. So what does that mean? Our new number is going to be 1 second, let me just clarify that. It is going to, and let me erase this. It is going to be 69.1 times 10 to the fourth, okay? And our top number is going to be 2.76, okay, 69.10 times 10 to the fourth. And now this is much easier to add, okay? Our base is going to be 10 to the fourth, and 69 plus 2, or we can say 69 plus 3, right, is going to be what? 69, 70, 71, 72, 73, right? And this is going to be our answer. 69, or I'm sorry, it'll be 72. 72. All right. Now the answer choice may be put in this form where you have 72 times 10 to the fourth, or they might want you to convert it back to 10 to the fifth, okay? So how are you going to convert it back to 10 to the fifth? Okay? Well, let's see. If we are at 72 and we want to convert it to 10 to the fifth, what we have to move left and we have to add, right? We have to move left and we have to add an exponent. So we moved left, okay? And so our new exponent has become 7.2. Let me just erase this. And because of that, we have added from 4, we added 1. And so when we converted it, we got 10 to the fifth. So both of these numbers are right. It can be written as 77.2 times 10 to the fifth, or it can be written as 72 times 10 to the fourth. Alright, so now let's go ahead and do a complete example, which has both multiplying and dividing of exponents, which is most frequently what you're going to find on any physics-based question on the MCAT or even chemistry-based question on the MCAT where you have to multiply or divide exponents. Alright, so let's go ahead and rewrite this. So let's just say the next exponent, or the next thing we had to do was we had to multiply 3.2 times 10 to the 4th multiplied by 4.9 times 10 to the negative 8, and then we had to divide by 2.8 times 10 to the negative 7, okay? Alright, so how would we solve this, right? So the very first thing that we have to know is we always do the top operation first, right? So let's go ahead and solve this, alright? So if we round this, we can rearrange this to be 3 times 10 to the 4th times 5 times 10 to the negative 8. And we're going to divide all this by 3 times 10 to the negative 7th. Alright? So, let's go ahead and solve it then. So 3 times 5 is 15. And 10 to the 4th, remember whenever we're multiplying exponents, what we have to do is add. So 4 plus negative 8 is going to be negative 4, right? And then we are going to go ahead and divide, right? 2.8, we rounded to 3, right? So this is going to be 3 times 10 to the negative 7. 3 times 10 to the negative 7. All right. And I'm just going to go ahead and erase this. All right. Just going to go ahead and erase this so we get a little bit more room so we can solve, okay? I'm just going to get a little bit more room so we can solve, okay? So we're going to come over here and we're going to go like this. 15 divided by 3 is 5. And negative 4 minus negative 7 is what? Is 10 to... Negative 4 minus negative 7 is 10 to the 3rd. Right? So this is our answer, right? So once again, we have to take into account, did we round up or down, right? So let's look at this. So when we multiplied, we rounded here. We remember we made 3.2 into 3. We made this into 3. We made this into 5. And we made this into 3, right? So I would think that since the biggest exponent here that we used was 10 to the 4th, right? Remember we talked about the base. 10 to the 4th is much bigger than 10 to the 8th, and 10 to the negative 8th, and 10 to the negative 7. So since we use 10 to the 4th, we would have to consider that we rounded down here. So our actual answer choice might be something slightly greater than 5 times 10 to the 3rd. It might be something like 6 times 10 to the 3rd. Alright guys, so the next concept that I want to talk about is proportions, okay? And proportions are going to be very important for the MCAT because these are probably going to be some of the more easier questions you'll get. So these questions are give me points questions, okay? And what I mean by that is that the questions are very easy, okay? And when I'm talking about proportions is that you need to know the relationship of different variables in an equation. Okay, so for example, if I gave you you know you know the electrostatic force equation, okay, which is K times Q1 times Q2 over R squared, okay, and I don't know. Let's just say that I said that between these two points, Q1 and Q2, okay, I increased the distance 4 times, okay, and let's just say okay, or I increased the radius. Okay, I increased the radius 4 times, okay? So how will that affect, our electrostatic force? So in terms of proportions, what we need to consider is if we had a value of 1 first, and we increase that to 4, okay, how would that change our electrostatic force? Well, if we look at this, and let's just say everything was constant, besides the radius and the electrostatic force, and we increase the distance by 4, that would be, right, a change of 16, right? 4 squared is 16. So, what that is saying is that the force would have decreased by 1 over 16. So the new force, electrostatic force, will be decreased to only 1 over 16, right? Because if you increase the denominator, then overall, your overall value is going to decrease, right? So that is one concept that you need to understand. If you memorize these equations, okay, it will be easier for you to get to those relationships. You see? That is one idea that we need to look at. So I really want you to get this concept down. So because this is how the questions will be phrased. They'll give you maybe a force or density or something, and they'll tell you that they manipulated one variable, and they would want you to find out what's going to happen to the overall value. And so it's very important that you understand what's happening here. So let's think about this. You have a value, so let's just say you have a value of 1 over 2. Okay, so this is how I look at it. So you had a value of 1 over 2, and then you square that value, right? It's going to turn into 1 over 4, right? If you held the numerator constant, right? Overall, we know that 1 over 2 is greater than 1 over 4, right? And what caused this to manipulate from 1 over 4 or 1 over 2 to become 1 over 4? It was the idea that we squared this bottom term, and that's how the value decreased. So what we did here is we increased the denominator exponentially, and that resulted in an exponential decrease in the force. And that is a proportion that is a relationship that MCAT tests frequently, okay? Now let's look at another value, right? Another thing is, let's just say, you're looking at the normal force, right, of an object, okay? Acceleration is going to be constant because it's a normal force, right? If we talk about a free body diagram, right, normal force is going to oppose the floor, right? So we're looking at the acceleration, which is going to be 9.8 meters per second squared, right? So it's always going to be constant. So let's go ahead and say that's constant. What's going to happen if we increase mass, right? Well, force is going to increase proportionally, right? Because the relationship is 1-to-1, right? Here, in our electrostatic force example, that's not true because the denominator is squared. And here, all values are proportional. So there's a difference. So the difference between these two equations and these two relationships is the difference between inverse proportions and normal proportion. And that is something that is frequently tested on the MCAT. So we'll do more example. Let's do one more example just so you kind of understand the relationships, okay? And remember that all of this is this should not be the only material that you look at. This is just supplementary information, and it's just meant to kind of be a concept review of items that you should remember while taking the MCAT. And this is all things that you should have pretty much ingrained in your mind before you go into the MCAT, okay? So especially this math section is something that you definitely need to have. All right? So let's go ahead and look at another example, okay? Okay. Let's look at the gravitational force, okay? So the gravitational force, we have the gravitational constant, and then we have mass 1, mass 2, and the radius, right? So in this example, let's look and see what is going to happen if everything is held constant except for the radius. Once again, this is what? An inverse relationship, right? Inverse. All right. So let's just say this time we multiplied by 2, okay? So instead of having 1, we changed the radius went from 1 to 2, okay? So what has happened to our force? All right? Here, our force went from 1 to 2, which is a change of 4, right? So the difference between 1 and 4 is a decrease of 1 over 4, right? That 1 over 4 will be reflected on the other side as well, right? Because we increased, now the gravitational force will be 1/4 of what it was before. All right. So now let's look at the other. Let's look at it the other way. Let's just say we decrease the distance. Okay, we decrease the distance between these two objects, and we are assessing the gravitational force. Okay. All right. So now instead of 1 squared, which is 1, now we have decreased by half. What's going to happen here? Now, instead of decreasing by 1/4, we have increased by 1/4. So increased by 4, right? So if you want to look at this, right? So this is the way I look at this is kind of like this: 1 over 4. So 1 divided by 1 over 4 is the same thing as 1 times 4, which is equal to 4. So, in this circumstance, right, the gravitational force has been multiplied by 4. You see the difference? All right. And that is, when we're talking about inverse proportions, you need to be able to know what happens if there's an alteration in terms of an increase in the radius or a decrease in the radius. And based off of the equation, you need to know how it's going to be affected, whether that is based off of, exponents, or just a normal variable, right? And you needed to be able to decipher that. And this is where confidence comes into play too, because confidence is very essential for you to do well on the MCAT. So let's go ahead and clear this up. So clearing this up. All right. And let's look at one more example where we're looking at direct relationships, okay? All right. And it can be as simple as they might give you a question about manipulating density, okay? Density is equal to mass over volume, right? So let's just say that, I don't know, they held, they held the, well, actually, yeah, let me give you another example. This is not that great. So let me see, what other example can I give you guys? Okay, so let's just look at this example again, right? So we have force, and we have mass and acceleration. Okay, acceleration is always constant. Let's just say that acceleration is constant, but what happens is, mass increases by 4. Well, what's going to happen to our force? Well, our force, all right, will increase by 4 times too. Now, so let's go ahead and erase that. Now what's going to happen if we decrease by 4? We decrease by 4. We decrease, or let's just say we divide by 4. So we decrease by 4, or we could say, it's better to say we multiplied by 1/4, okay? Multiply by 1/4, or we decrease by 1/4. Well, our force is going to be 1 over 4 times Fg, right? So it decreased by 1/4. Same difference, all right? Then you might have examples where, they might say that, force is held constant. So they might give you an example where force is held constant. And then they might ask, what will happen if acceleration increases 2 times, right? Well, in order for your mass to remain, or in order for your force to remain constant, right, you would have to do what to the mass? You would have to multiply by 1 over 2, right? Right? And the way I think about it is, if force is equal to 1, right, 1 Newton, and, you increase your acceleration to 2 meters per second squared, right? And your mass is equal to 1, or what 1 kg, that's going to equal to 2. That's going to be 2 newtons, right? So that cannot equal 1 newton, right? So how do we make it equal to 1 newton? So let's go ahead and look at this question. 1 over n is going, so you would have to multiply this mass by 1/2, right? So 1/2 times 2 will equal 1 newton, right? So 1 newton will have to equal 1 newton. So similarly, we can look at this equation and say that if we are going to increase, acceleration by 2 times, then we have to decrease mass by 1/2. Okay, so that our force remained constant. All right. So I'm going to erase this. And now let's go ahead and go back to our electrostatic force, okay? Our electrostatic force equation, okay? So our electrostatic force is equal to our K constant times Q1 times Q2 over R squared, right? If we're going to hold electrostatic force constant, okay, and we multiply the radius, right, or we increase radius by 2, then how much must, let's just say the equation was electrostatic force is held constant, okay, and R squared, right, is increased by a factor of 2, which means that it has gone up by 4, right? Which means that this has decreased by 1/4, okay? Our electrostatic force has decreased by 1/4, right? How much, so let's just say the question says, by what factor must Q1 have in terms of charge and coulombs for these 2 electrons who have same electrostatic force, okay? Well, the best way to solve that is to realize that if the force has decreased by 4 because we have, squared the distance, which caused it to decrease by 1/4, the electrostatic force, then in order to negate that 1/4, we have to multiply 1/4 of the electrostatic force by 4 to get back to the original value of Fe, right? And how are we going to do that, okay? Well, what we have to do is we have to multiply Q1 by 4. All right? So we are going to multiply Q1 by 4. So the answer will simply be 4Q. You see that? The answer will be 4Q1. That will be the answer. Our final lecture, or our final part of the lecture, will focus on graphs. I'm just going to go ahead and draw some of the graphs that are important for you to know, and I'm going to draw some model equations that you should use to kind of mentally understand what type of equation you're dealing with. All right. So let's look at this. So we have y, and we have x, and let's just say we have just a linear equation right here. Right. We know that one is just going to be y is equal to mx plus b. Okay. Right. This is just this is just a linear relationship, right? Linear, right? This is how we know 5x plus 6. This would be more of just y is equal to 5x, right? But this is kind of like an example. I just wrote that as an example. Let's just draw another one. So we have y and x. So this is the exponent, right? Right. So the exponent is just going to be y is equal to x raised to n. Examples of this would be, right, y is equal to 2 raised to x, right? And just like that, we also have the opposite, which is the inverse of that, which is y is equal to 1 over x raised to n, right? And that is going to be the inverse of our exponent. And this would be more of something like y is equal to 1 over 2 raised to x. All right, so those are 3 graphs that you need to know. And then you also need to know, you're going to also need to know what's going to happen when we're dealing with intercepts. Right, so we have our linear equation again, right? Y, x-axis, and then all of a sudden, we have an intercept at 2, so that's going to, right, give us our b component. So an example is going to be y is equal to 2x plus 2, right? And now let's go ahead and look at what's going to happen if we do the same with our exponential relationship. Right, so we have our y-axis and our x-axis, and we have the same equation here. Y is equal to x raised to n, but this time we add an x-intercept. So let's look at that. Y is equal to 2 raised to x plus a value of 2, right? So now we have an intercept at 2, and the relationship is very similar. Now we just connect the line. Let me just draw that a little bit better. Right? And we can draw that relationship as well. All right. And that's about it for MCAT Math. These equations that I showed you, for examples, in these graphs that I showed you, especially the graphs, are something that you need to be able to manipulate. You need to be able to manipulate those graphs. Okay, so you need to be able to manipulate those graphs. Okay, easily. Okay, so you should be able to look at an equation and automatically tell if it's a linear relationship, an exponential relationship, inverse exponential relationship, or a quadratic relationship. Okay. You need to know the unit circle really well, because when we're going to get into physics and get into the vector components of force, right, we need to know exactly how to compute the cosine of a degrees or the sine of the degrees, and we need to know the value of that degrees, right? So we need to know that, right? We also need to know the relationship between the different equations and how to manipulate those proportions, right? And we learned that, and we learned the importance of those, right? We also learned how to add, multiply, and so in that way we have dealt with scientific notation as well. Basic trigonometry, I already explained why this is important with the free body diagram in physics. And we talked about square roots and why that's important, and the importance of rounding as well. So in conclusion, I just want to thank you guys for watching my first video lecture on MCAT Math, and in my later videos I'll be talking about physics, and then our next video is more specifically going to be about translational motion, and then I'm going to try to get into chemistry, then OChem, some biology, and biochem. And then I might do, psych soc. I'm not too sure yet. But this is going to be the sequence of my lectures. I'll try to include more pictures. This was my first video recording, so there was a lot of background noises. I'm sorry for that, but hopefully I helped you guys on your journey to becoming doctors, and I hope this video helped. Thanks.